whenever we talk about our interval, okay, and where things can go and where they can come from, the big ones that we will worry about are going to be whenever we have inverse sine, inverse cosine, or inverse tangent on the outside. Okay? Where normally what we talked about yesterday is you have certain intervals as far as where everything can be. Okay? What you need to do if something is outside of these intervals. So if something is outside of negative pi over 2 and pi over 2, or if it's outside of 0 to pi with cosine, what you need to do is you need to basically find the value that's going to make it true. Okay? So what that means is, basically it's like if we go to our unit circle. Okay? And if I have my circle here. Okay? If we just write everything in terms of radians, so I would probably put this somewhere and kind of draw it as you go so you can kind of understand as far as where I think it'll make sense once you do it, but I just want to make sure that you kind of have everything as far as where it's going to go. So whenever we did this, we had our standard, we were at 0 or 2 pi. Then we were at pi over 6. We were at pi over 4. We were at pi over 3, and then pi over 2. In this case, whenever we deal with anything in quadrant 1, remember that all functions are positive. Sine, cosine, tangent, everything's positive. Okay? Now, I'm going to look to the right, or on the bottom right side, whereas normally it would be 11 pi over 6. If we peel back, though, so that's if we go in a positive direction. If we peel back, where is it actually? Or what did we do? Yeah, negative pi over 6. Whereas if we would go all the way around, we would be at 7 pi over 4. But if we peel back, it's going to be at negative pi over 4. Same way then, if we would go all the way around, we would be at 5 pi over 3. But if we peel back, we're at negative pi over 3. If it's anything on that right side, everything's going to be okay. Okay? The big thing is whenever we're dealing with the left side, okay? Whenever something isn't normal or we're on that left side of our circle, now in this case, which functions are positive? What are going to be my positive functions down here in the fourth quadrant? Which one's always positive? Cosine? So then if cosine's always positive, what's always going to be negative down here? Sine and tangent, right? So if at any point, normally what we would tell you is that the interval needs to be from negative pi over 2 to pi over 2. Well, here's 3 pi over 2. What is 3 pi over 2 the same as? Negative pi over 2. Okay. So we either have the top side where we go in a positive direction, we're at pi over 2. If we go on a bottom side, we're at negative pi over 2. Everybody good there? Now, I'm going to go down to the third quadrant. Okay. Or let's just work it around. Let's just keep going to the second one. So normally we would be at 2 pi over 3. And then we would be at 3 pi over 4. And then 5 pi over 6. And then here's just pi. Okay. Now, if at any point that we end up outside of our interval, okay, so say it might be sine of 5 pi over 6, okay, what we've got to do is we've got to figure out where is this actually going to be in terms of, like, how can I rewrite 5 pi over 6? What did I have to do to peel back in this direction? Say it. What are you thinking? Ethan, what did you say? Huh? Yes, but what did we come back to, though? Negative. Right? We went back pi over 6. What's going to happen when we go here? Negative pi over 4. And then when we come all the way back to the inside, we're going to be back at pi over 3. Notice that these values match up with the values here. Okay? Now, one thing that we've got to make sure is, depending on which function we're talking about, okay, just like we did down in quadrant 4, what's positive in quadrant 2? Sine's going to be positive. So that means, as far as negative, we're going to have cosine and tangent. Okay. So those are kind of giving you like where your reference angles are. We want to rewrite anything that's not in our original interval. We want to rewrite it as like pi over 6, pi over 4, pi over 3. We want to put it into, or negative pi over 6, negative pi over 4, negative pi over 3. We want to put it into our interval. Okay? Or be able to rewrite it to where it is in our interval. Does that make sense? Same way if we would continue to wrap it all the way around to where I would normally be at 7 pi over 6, I would be at 5 pi over 4, and I would be at 4 pi over 3. What did we do to get to here? Pi over 6, pi over 4, pi over 3. Now, if we end up down in this third quadrant, the only one that's going to be positive down here is going to be which one? Tangent's going to be the only one that's going to be positive. Wrote that backwards. So that means if anything down here that we have a value, like if we say, hey, we're going to go outside of our interval, okay, and we're dealing with sine or cosine, then that value needs to be negative if we're dealing with sine or cosine. Now, the only cases that this is going to apply to, as far as when you can kind of go outside of your area, is whenever we're dealing with inverse sine, inverse cosine, inverse tangent on the outside. Okay, whenever we're dealing with that on the outside, then we can come back in and kind of look at different spots.